You're listening to SpaceTime with Stuart Gary.
Astronomers have discovered weird structures shaped like double peanuts in two nearby galaxies. The discovery, reported in the monthly notices of the Royal Astronomical Society, are thought to provide new clues about the history of these galaxies. The pair, NGC128 and NGC2549, are both disc-shaped galaxies, sort of similar to the Milky Way in appearance. They're located roughly 200 million light-years and 60 million light-years away, respectively, in the constellations Pisces and Lynx. Using data from the Hubble Space Telescope and the Sloan Digital Sky Survey, the researchers realised that the two galaxies they were studying were quite exceptional. The astronomy team, including the study's lead author Bogdan Kamber from Swinburne University, detected the unusual structures using newly developed imaging software. The authors detected this unusual double peanut shell shape, which they believe was formed by the distribution of stars bulging from the centres of these galaxies. The shape sort of resembles two peanut shells, with one neatly nesting inside the other. The peanut shell configuration was visible in two separate layers within the galaxy's three-dimensional distribution of stars. It's the first time such a phenomenon has been observed. Although the bulges of both galaxies were already known to display a single peanut shell pattern, astronomers had never before observed the faintest second structure in any galaxy. These structures each consist of billions of stars, typically spanning up to a quarter of the length of the galaxies. Astronomers believe the peanut-shaped bulges are somehow linked to the bar-shaped distribution of stars that's observed across the centres of many rotating galaxy disks. Both these galaxies contain two such bars, and it's thought one way these peanut-shaped structures could be forming is when these bars of stars bend above and below the galaxy's central disk. Because of that, this study may shed new light on the peanut-shaped bulge of our own Milky Way galaxy, which some astronomers suspect also contains two stellar bars. This instability mechanism could be similar to water running through a garden hose. You know, when the water pressure is low, the hose remains fairly still. In the case of these galaxies, the stars remain in their usual orbits. But once you turn the water pressure up high, the garden hose starts to bend, usually spraying water in your face. Funny how they do that, isn't it? And the stellar orbits may be bending the outside of the galaxy's disk plane in the same way. The discovery is exciting because it will enable scientists to more fully test the growth of bars in galaxies over time, including their lengths, their rotational speeds, and also periods of instability. The team will now run computer simulations to try and emulate what they're seeing in both NGC 128 and NGC 2549. Kamber says if they can repeat their observations through these computer simulations, it'll provide new clues about galaxy evolution, including our own Milky Way.
Basically, the whole discovery has to do with general class of galaxies. They're special galaxies, and they're not so well known. So essentially, what happens inside these, in the central stellar distributions, is that they're actually shaped like two-lobed sort of peanut. Their bulges, which is what their central stellar distributions are called, are shaped like this. And, you know, people have known about these objects, you know, ever since the 50s. But what we found recently is essentially two such peanut bulges in a single galaxy. So essentially, there's a small peanut bulge nestled comfortably inside a bigger one that's 3 to 5 times bigger than the smaller one.
So we're looking at these barred spiral galaxies, and as you looked at them, you noticed in the central hub, in the bar region of these galaxies, the bar was shaped sort of like a peanut.
Yeah, that's exactly right. So it's the central part of the bar that people believe what happens is that it starts to bend, and it gives this sort of bow tie or X or peanut shape, as is usually called in the field.
And I guess our own Milky Way galaxy, being a barred spiral, may well have a similar sort of shape.
It does actually. Our Milky Way has a peanut bulge, and this has been known. People have been studying since about 2013 the bulge of the Milky Way, and it does indeed seem to have a bulge, and a peanut bulge. And we're lucky enough to see it because we're outside of it in the disk. So we have a good vantage point.
As we looked at these two galaxies that you guys have been studying, it wasn't just a single peanut bulge you saw, but there were two bulges there.
That's right. There was a small one nested inside a bigger one.
What do you think is causing that?
Well, the formation mechanism is actually a little bit complicated. So essentially, you have to imagine a bar, and you have to, you know, visualize it looking side on. So if the two ends starts to wobble up and down, then this is going to give rise to such a peanut distribution. And this wobbling is called in the field a fire hose instability because the bending mechanism is similar to water running through a hose at high pressure and causing it to bend. So what we think may be going on is that these galaxies have two bars, and each of these bars has its own peanut. So essentially the mechanism is, well, it's a little bit complicated, but it's a bar bending. So the orbits of the stars are bending because of an instability. And the instability, in principle, is similar to what happens inside a garden hose when you turn the water on high. It starts to bend and twist. And if it wobbles a few times, then it gives rise to this peanut.
And has this double peanut been seen before? Is this the first time it's been noticed?
This is the first time, actually. People have known about single peanuts, but really, this is the first time that we see a twin or a double structure like this. Now, there are other sorts of theories out there, but these galaxies do show the signatures of two bars at different radii.
What do we know about these two galaxies? How well studied have they been?
Well, there haven't been many studies. Basically, people have known that each of these galaxies contain a single peanut, but the other one was pretty faint. It was really when we started analyzing it with our new software here that we were actually able to detect the second one. Earlier in my PhD, I sort of developed a software that was meant to analyze the way the galaxy's light is distributed with very high precision. Compared to what we had before in terms of studying galaxies, this was kind of like switching from a magnifying glass to a microscope. So Alistair and I started studying peanut galaxies with this, and lo and behold, we found really delicate, faint structures in a lot of them, and in particular these double peanuts.
What makes a spiral galaxy become a barred spiral?
The whole thing is an instability. So you have to imagine a flat disk of rotating stars, and that disk at some point in its lifetime becomes unstable and forms an elongated distribution called a bar, because it's actually bar-like. And then it's this bar that becomes unstable and starts to wobble and bend, and that gives rise to the peanut structure.
And where to next? We're going to look for more peanut galaxies? I guess that's got to be the next thing, to see if we can find any more. You've got two examples at the moment.
That's right. We have two examples. We're hoping to find a lot more. And also the next step is to look at pretty much the closest peanut bulge out there, which is that of the Milky Way. So we'd really like to see how our own galaxy fits into the picture. And something else that we're also very keen to look into is the formation mechanism of these double peanut structures. And we're kind of hoping to attack this through simulations. But that's a little bit more long-term.
That's Bogdan Kamber from the Swinburne University of Technology.